So let's work on an example for ray tracing, and we're going to first calculate all of our focal points and distances, and then we'll take a look at the ray trace diagram. Now before we start into diving into calculating things, let's think about the setup. Our first object is 25 centimeters from the center axis of the glass lens. And then there's a 24 centimeter gap or distance between the glass lens and the quartz lens. And then between the quartz lens and the diamond lens, the center's axes are 15 centimeters apart. Now the glass we see has both positive radii, which means that this is a double convex. The quartz has two negative radii, so that means this is a double concave. And our third lens has one positive and one negative radius, so this is some kind of meniscus lens. So we've defined these lenses. We know the distances between the axes of the lenses, and we can go through now and calculate our distances of the images. Now, the way that this will work is we'll calculate our image for the first lens. So we'll have the image of the first lens. Will become the object of the second. And then the image of the second lens becomes the object to the third. So we just work at one lens at a time from start to the finish, just realizing that we are going to have to calculate. If I know the image for the first lens, I'll have to calculate the distance so that it becomes the object of the second lens. So let's start first by calculating the focal points for each of the lenses.